Good afternoon. My name is Mustavi, and I would like to welcome you to our project showcase on keyword analytics. Before we get started, I would like to thank each and every participant for joining this session today. Me and my team have been working very hard on this project for the last 4 months, and I would love to show it to you today. So let's talk about what is keyword analytics. Keyword analytics is a social media monitoring tool powered by big data and AI. And what it does is monitor the latest social media trends in real time, giving you detailed insights on each of those trends with stunning visualizations. And one of its core features is the ability to track any trend of your choice. So let's talk about who this is for. Well, keyword analytics was built and designed with the digital marketer in mind. And our product aims to help the digital marketers by providing them with valuable insights to promote their businesses and products and helping them keep track of the latest social media trends so they can position their marketing efforts accordingly. And to add a cherry on top of that, it is also designed to track social media performance of their business or product. So now that you have a rough idea of what keyword analytics is and who it is for, we're going to get a bit technical and talk about what the big data platform is and how it's designed. So as of now, keyword analytics is completely based on Twitter. However, it does have the potential to support other social media platforms in the future. So this is how our current platform is positioned. I'm going to give you a high-level overview of the current system architecture. So we gather the big data from Twitter using our on-premise server, which does the processing. Then after it uploads it to our NoSQL high-performance database on AWS Cloud. Another cloud-based server is connected to the front-end web host acting as the API endpoint for that. And so now that you have an understanding of the whole system itself, let's talk about how we collect the big data to provide you those insights. We collect huge amounts of publicly available data using the Twitter API, which allows us to receive data in real time from Twitter, and it is done around the clock. But of course, there are major challenges to gathering the data. And especially one of the problems we faced with the Twitter API was that it kept disconnecting from the stream. So how we overcome those limitations with the Twitter API is quite interesting, and not a lot of people have done it in the past. And so what we did was use a stream processing platform known as Kafka. And essentially what Kafka did was separate the data collection part and the data processing part completely. And this gave us the opportunity to do advanced data processing in real time. And this also allowed us to track more keywords near the theoretical limits of the Twitter API. So when you're collecting big data, you always have to...
We lost your voice.
Oh, really?
Yeah, it's better now.
Oh, all right. You can hear me, right?
Yeah.
Okay, so when you're collecting big data, you always have to deal with bad quality data, and you somehow have to transform that data into useful information. And there are a lot of big data processing steps we take, but I'm going to show you the ones that I think are interesting. So the first is language detection. So although you can have the Twitter API filter out those tweets, we frequently deal with the tweets that are not either in Thai or in English. So we use a language detection classifier to detect what language the tweet body is in. Then we extract the keywords or hashtag from the tweet body and use them later for calculating time series. And finally, we do spelling correction using something called an edit distance algorithm, which we use to calculate the minimum number of edits required to correct the spelling of a trend. So now let's move on to one of the key features of the system, which is trend analysis using time series. As we collect data in real time, we count the number of occurrences for a particular trend. Then we group the data together to construct a time series by hour. This is how the time series is constructed. The time series is constructed at the API level, compiling all the time series data by hour together for the whole day. And so this platform uses deep learning and neural networks to predict the sentiment of a tweet. And I'm going to show you how we do that here. So in order for our system to understand what kind of sentiment they can assign to a tweet, we need to convert the tweet body into something the neural network can understand. And since neural networks only understand numbers, we separate the words into tokens, like this you can see here. Then we conduct normalization by finding the root of the word of the token, root word of the token. Then we finally remove the stock words like is, him, her, etc. Then finally, the text data is fed into the convolutional neural network. And now, although convolutional neural networks are used for image processing, it has shown great promise in text processing as well. What we do is convert each of the word into vectors, which are basically numbers. And the vectors are then multiplied by weights and put into various convolution and pooling layers. Then finally, it is fed into the neural network, and by using the fully connected network you can see here, it produces the sentiment for the tweets. So my friend Sorasit will be talking about the Kalman filter and how we use the Kalman filter to smooth out the raw data we get from Twitter. All right.
Okay, so thank you, Mustavi. Can you see my screen now?
Yep.
Okay, so next I will talk about Kalman filter, which we have used in our project to filter the noise in our data. So you might ask, what is the noise in our data? This is from when we get the data from Twitters. Sometimes we receive duplicate data, and sometimes there is also missing data. So now, what is Kalman filter? Kalman filter is an algorithm used to do estimation that, given the data that is noisy, the Kalman filter could quickly find the true value of the object that we are trying to measure without needing to wait for a lot of data points to be fed into the algorithms. The reason we use Kalman filter is because of two main points. Kalman filter does not require a lot of memory, where it only needs to keep only the previous state of itself. And another good thing about Kalman filter is that it does not need a lot of computational power. Now that we know what is Kalman filter and why we use it in our project, I will next show you how we use Kalman filter to do prediction. First, let me make a clear point that there is two different kinds of prediction that we would do using Kalman filter. The first one is to predict the true value of the frequency at the current time, or I will call this step as filtering out the noise. And the second one is to predict what might be the future frequency of each topic. To have a better ideas about how we use Kalman filter in the project, I will show an example of how Kalman filter comes up with the output for both predicting the true value and predicting the future frequency. To start, I will talk about one of the most important Kalman filter parameters that we have adjusted, which is called transition matrix. This matrix directly affects Kalman filter predict frequency as shown in the slide. Looking at the sample input, we will do the calculation of Kalman filter predicted state. Please note that even though Kalman filter caught this step as predict, the answer is not yet final, and it needs to go through another step, which I would talk about in the next slide. The next part is called correction or updating step, whereby using Kalman gain, the Kalman filter would learn and adjust whether or not it should give more weight to the predicted frequency or the measured frequency. And then it would adjust the predicted true value accordingly. After getting the true value frequency, we have completed the first prediction for Kalman filter. Moving on to the next prediction, predicting the future frequency. Once we have gotten the true frequency value from Kalman filter, we could then use that value along with the velocity to then predict the frequency for the next time step. We repeat all these steps for each time the new data come in, and that would about sums it up for Kalman filter. Now my friend Chawalit will talk more about the front end part of our project. Thank you.
Okay, hi, I'm Poom. I'm responsible for convert the useful data from the backend to visualization in form of web application. And this web application we have designed for a digital marketer who looking for some trend to make a online campaign for it. And in our web app, we have designed for two main area: this exploration area and the dashboard area. The first part at the right side, as you can see that we have two tables. This an exploration area because sometimes digital marketer they don't know, have no idea what to looking for. So we provide some interesting trend for them. First is delivery trend ranking table. We got this list of ranking from the uh, Twitter API directly. So it's the direct trend ranking from the Twitter API. And next we have another table with this interesting trend. This interesting trend is a trend that we have select that we think it is interesting and the user should be looking for it. We have the criteria to select the trend by three factors. First is sentiment score. The better sentiment score, it will be here. Another is trending score and trending probability. And next we have the dashboard area here. So for example, I am a digital marketer. I don't know what to looking for here. And I see something about CP, TCP here. I click on it. So now the dashboard will be updated and I can see that I don't know what it is. So I look at comment and I can see that it is something about the CP company that people talking really bad about it. We have the first element here is the tweet sentiment pie chart. We can see the ratio between positive and negative comments. For example, I want to compare between the good and bad only. Now I can see that it's more than 80% is talking bad. So now I can come to explore the comment why. Now I can see some morning face here is neutral comment, and I can see that people is complaining about the CP company. And next we have the, let me go to another example, train treasure. We have some general information such as the tweet volume, the number of like, number of retweet, and the sentiment score, trending score, and trending probability here. And now come to the analysis part. We have provide time series and the bar chart for user. For time series, it shows the volume of Twitter of the day, hourly for 24 hours. And we can see that there are two lines. The first is the blue line, which represents for the original volume that we get from the Twitter. And we have the red line with the smoother via common filter that we remove the noise to predict the true value. And we also have a bar chart here to see if the trend is increasing day by day or is start to decreasing. And the user don't have to only to look for the trend we provide here. They can also register for some trend for our system to track. For example, I'm a digital marketer. My company having some campaign about China. I want to see that how people are talking about China now. So I can type in China here and I select the duration for system to give tracking. I will give the track the China for 1 month and register for it. So now the register trend will be in the bottom here, China. And now I can click on it. And I can see that, oh, the China have been like on the trend for every day. So the trending probability is quite high, but seems like the sentiment score is not good because a lot of people like complaining something about China. So I might be careful to do some campaign about China for the image of my company. So this basically how digital marketer can use from our web app. I will give the mic back to Mustavi for the conclusion.
All right. Okay. Can you see the screen? Okay. So yeah. So hope you liked our demo. So to conclude, me and my team pushed the boundaries of big data and AI to bring you this unique platform today. So what we are now at the beta stage right now, and we're working out all the quirks and adding new features to it on a regular basis. And if we get the opportunity to work more on it later, I'm sure this has the capability to become a leading social media monitoring platform in the future. So that is it for our demo and presentation for keyword analytics. And before we move on to the Q&A, this project, I would like to tell you that this project started out as our senior year project. And we had great support from, help and support from ISL. And so I would like to thank my entire team, ISL, for making this possible, especially Ajahn Kwan and Prince for helping us with the Thai sentiment classification, and of course Ajahn Tap for giving us the opportunity to work on this. So now we are open for general questions and any suggestion about our platform. And of course, you can shoot me an email if you want, if you have any suggestions for the platform itself. That's it.